Hi, this is Paul from Fossil Tech. In this video, we are going to deal with the estimation for the sum of a convergent series, focusing on how to compute the remainder or error using comparison. Let's see the outline. First, I will introduce the sum estimate and the remainder estimate for comparison test. Then we will practice one question together about how to use the estimate. Let's see the material. Here we have a question, and suppose we have a series, a convergent series. However, the sum is not easy to find, so what do? We have to estimate the sum, right? And therefore, we have to compute the error or the remainder. And here is the result for this estimate when we're using comparison. Let's see. And the sequence, the series, okay, we say A converges, and this is a positive C series. Let me highlight. What we deal with is positive because we know. Okay, so for comparison, we always deal with positive series, right? Okay, and S describe the sum of this convergent series, and the Sn is the partial sum. Okay, so the first. And how to estimate the sum? Okay, the common one is use partial sum to estimate the sum. However, we have a remainder. So what is the remainder? The remainder is the difference between the sum and the partial sum, which means the error, right? Okay, so how to find this error? How to compute this error or the remainder? So we have to use this. And if in our question we use a comparison test, which means we have another convergent series, we call the B. Can you see? B is the larger one, right? A is the smaller one. If B converges, A should be convergent, right? Okay, so let me look at the bigger series, the larger series, B. T is the sum of the series B. The Tn is the partial sum for B, and therefore the same. We have a remainder for the B series, which is the distance, the difference between the sum and the partial sum. Okay, and finally we have these big results. Can you see? And the remainder for A series is controlled by the remainder of the B series. And this looks obvious, right? Why? Because A series is controlled by B series. Therefore, the remainder of the A series is controlled by the remainder of the B series. Does this make sense? Or let me just show you something so we can see this exactly is true. We look at the A series, which is the one we want to estimate. Let me use S to describe the sum of the series A. So S should be this, should be A1 plus A2 plus that goes to AN. Okay, and then continue AN plus 1 plus AN plus 2 and goes on. Can we see? Now what do we have? We have the first n terms put together is what? Is a partial sum, right? So we describe as Sn. You know this is just a partial sum. This is an estimate for the sum. So where the error is here. Okay, this is the error. Or we say this is the remainder. Let me put it here. So we call it Rn. Usually we call it is the remainder or the error, you know. Okay, so now what do we have? So we just say S is approximated or estimated by the partial sum. And you know this is what? This is just an estimate, okay? It's an estimate for the sum. And you know the remainder now is what? Is error, right? Okay, so we put it here together. Can you see this is the basic? Okay, so now we look at the comparison. Okay, and we see this remainder Rn, which is the remainder for A series. Okay, I say this is controlled by what? Okay, where is Rn? Rn is at here, right? So each term, let me highlight this part, because each term in A series is controlled by the corresponding term in B series. See, therefore what? Therefore A n plus 1, okay, it should be controlled, which means less than or equal to, by B n plus 1, right? And then A n plus 2 is controlled by B n plus 2, and then goes on. Does this make sense? Which means the remainder of A series here is controlled by the remainder of the B series, right? So this is the remainder of the B series. Let me write it down, okay? Which means remainder of the B series is Tn to describe. Okay, so let me highlight this, and this is the remainder for B series, which means this. Okay. So this is just the result, right? The remainder of A is controlled by the remainder of B. Of course, that's true. So how to use? And usually we do this. If we need to control the remainder of A, we need to find or control the remainder of B, which is Tn. And don't worry, usually when we use a comparison, do you remember? And we compare to what? And A compared to either P series or geometric series. Okay, for P series or geometric series, and the remainder is easy to control or to just find that out. And let me show you that the results, okay, in the remarks. Here the remark 1 is for the B series is a geometric series. Okay, and in this case, the remainder of the B series is still a geometric series, which can be found exactly. Okay, and let me show why. Okay, so first let me write, if the series B are wrote in this way, is the summation, like A is the first term, R is the common ratio. Okay, so m minus 1, right? So if B series is in this way, now I will going to write what is the remainder. Okay, so what's the remainder? The remainder should be in this, right? Start from Bn plus 1. The first n terms we already used as the partial sum. So start from this, and then m plus b, n plus 2, and then goes on. Okay, what is B n plus 1? Okay, which means A times R raised to the nth power, right? Okay, and then what is B n plus 2, which is A raised to n raised to n plus 1's power, and then moves on. Can we see now? Is Tn a geometric series still? Yes. Okay. Can we look at this? So the first term is A times n raised to the nth power. The common ratio we see is still R, right? So let me write down this, which means now what do we get? We will get the remainder is still a geometric series. And the first term, this term we see, is A R raised to the nth power. And the common ratio, okay, so you can see is still the same as R, right? Okay, therefore we use the formula. Okay, so how to find the sum? So the sum, which is this, and the first term A n R, 1 minus the common ratio. Is this the formula? Yes, we learned that before, right? Okay, so which means what? Which means we exactly find what is the remainder for B series. And remember, we go back to A series now. What do we have? Okay, so we will have these results. The remainder or the error for the A series, Rn, is controlled by Tn, right? Now, what is Tn? We already find A n raised to nth power 1 minus R. Can you see? What do we have? These results we call it the error control, right? Okay, we already find the contour of the error, so this is very good. The remark 2 is for another cases. For the B series is a P series. Okay, and this time you can, if you remember, we have these results for P series, and the remainder can be contoured, okay, by another method. Do you remember the name? We call it the remainder estimator for integral test. Let me show you here. Okay, so the second case is for this remainder estimator for integral test. Okay, what does that mean? So let me write, if the B series is like Bn is this, is P series, right? It says so n raised to the P's power. This should be convergent. Therefore, our P should be greater than 1, definitely. Okay, and what is the remainder? If you write the remainder, we call it Tn. Do you remember Tn is contoured by this integral from n to infinity, and the integral function is this. Do you remember this result? Okay, and the remainder, the result is like this. The remainder is less than this number, greater than another integral from started from n plus 1 into infinity. Okay, but we only need to use this term. Okay, that's the result from the last topic. And therefore, imagine now what do we have? Okay, and we do have the error contour for A series now. A series is the remainder is Rn. Rn is contoured by Tn. What is Tn? Now Tn contoured by this integral. Okay, therefore, and the error for A series is contoured by this integral, right? That does make sense? Okay, so how about this error? And this error, we know how to do calculation. Okay, and this integral is easy to find because there's a power function, right? Okay, so this is the error control for these cases. Okay, now let's practice questions together. And this is the question. And then we have two parts. The first part is estimate the sum. And the second part is to estimate the error. Okay, so let's go to the first. And how do you estimate the sum? Okay, so we say as part A. Let me go to C. Our series is here. Okay, to estimate the sum of a series, of course, this we have to show this series is what? Convergent. Why? If it's a divergent, that's meaningless to estimate the sum, right? Okay, so first, let me show is convergent. Why? Okay, so this is what is related to P series, right? We did this type of questions before, so easy. Let me just show the comparison directly. So our series general term is 1 over n third power plus 1. And easily to control by what? By 1 over n raised to the third power. Is this true? Okay. And because our fraction, the denominator is bigger, therefore the fraction is smaller, right? Okay. This is the comparison, direct comparison. Now, what do we have? The results for the bigger one. Okay. So for the bigger one is P series. Okay. Here. And this is what? This is just a P series. And in the P series, P equals 3, greater than 1. So convergent, right? Or converges. And then now we know. So by what? By the comparison test, the small, and this is the bigger one, right? The larger one converges, so the smaller one converges too. So we have a result, easy. And this is our series converges too, right? And we get these results by comparison, direct comparison test. Okay, so this is the first step. And then now, what do? We need to do estimation. Can you see? estimate the sum of the first 100 terms. What does that mean? That means we have to use the 100th partial sum, right, to do estimation. Okay, therefore here S is the sum approximated by S 100, right? The partial sum. What does this mean? This means the summation. Okay, 1 over n raised to the third power plus 1. And n is from 1 to 100, right? We add the first 100 terms together. Of course, you say, and this is a too big a calculation. It's not so big, okay? So you can do what? And you either use a calculator. Do you remember the calculator? We have a table, right? So you can do this. You can do calculator, okay? Or you can use a computer program. If somebody like, okay, computer program, you can do this approximation. Already get the approximation results is how many? Is 0.6864 and 538. Can you see? This is the first step. We already did approximation for the sum. Okay, now we go to the second step. How to estimate the error, which means how to control the remainder, right? Do you remember? So this is what? This is a link to the B series is a P series. We just did in the second remark. Therefore, what do we do? Okay, so we can use the remainder estimator for integral test, right? Okay, let me go and show you. Here is the second part. We have to use the remainder estimator for integral test, right? So how to perform? All we need is do this, and we should in the remark 2. So what is Tn? We control T first, right? And then we can control R. Okay, so Tn is this. Remember the formula is controlled by n, this integral n to infinity, and 1 over x raised to the third power. Why is this? Because of Bn. Do you remember what is Bn? Bn is 1 over n raised to the third power, right? Change n to x. Therefore, we have this formula. Then now, all we need to do is just do calculation. Okay, so this is easy to do. This is an improper integral, right? So we have to use the limit definition, which means we pick a t, approach infinity, and then do this normal integral from n to t. 1 over x raised to the third power dx. And this is see, this integral function is easy to do because this is a power. Let me write it in this way. This is the power. Okay, therefore we can find the entire derivative, right? So what do we get? We will get this t approach infinity. So now what is the entire derivative? Which is a power, right? So the power -3 plus 1 is -2. Flip, so we have the -1/2 here. And then times after plus 1, the new power goes to -2. Okay, so this is what? This is just the antiderivative. And then we're going to from n to t to find the difference. This is what? This is the fundamental. Okay, and we do calculation. How many? Imagine if t approaches infinity, this is infinity, 1 over infinity goes to 0. So this t disappear. What do we have is n. Plug in here, but be sure to change, right, the negative to positive. Okay, so easy to get these results is positive 1 over 2n squared. We just change a little bit of the form. Can we see? Now what do? We already control the remainder for B series, and therefore we can control the remainder for A series, right? So what do we have? So now we have this, and what do we need to do? The remainder for A series, which is the series we are there with, and is controlled by B series. That's the result, right? The major result. And then Tn we already found is not found, sorry. And is what? So Tn is controlled. We say Tn is controlled by 1 over 2 times n squared. Therefore, what do we get? Okay, so therefore we get Rn is controlled by this term, right? Okay, therefore, and then we almost get the results. And finally, all we need to do n is 100. Okay, so the error or the remainder are 100, and they can be controlled by this 1 over 2 times n is 100, right? So 100 square, and you do calculation. So you get it is 0.00005. Okay, so this is the answer. That's all. Thank you. I hope you enjoy learning on this topic. If you have any question, please leave your comment. If you like this video, please give me a thumbs up. Thank you for your support. Please don't forget you are very welcome to subscribe to my channel for more videos. In the next video, let's see. We will move to alternating series, which is a special type of convergent series. Hope to see you there. Thank you. Have a nice day. Bye.